All right. So here is an example of a percent yield problem. You're given here lithium hydroxide reacting with potassium chloride to produce lithium chloride and potassium hydroxide. So if you notice here, if you glance quickly at it, everything is already balanced for us, so we don't have to spend time balancing this one. Okay. So let's go ahead and read the rest of the problem. You're given 27.4 grams of lithium hydroxide, which I color coded in red there in the equation. And then it says here there's an unlimited amount of potassium chloride. So what that means is that there's an excess amount of potassium chloride, like there's enough of potassium chloride that you don't have to worry about it. Again, in reactions, the limiting reagent is what dictates the product side. Okay, so in this case, it's essentially saying lithium hydroxide is your limiting reagent. All right. So part A asks us for the theoretical yield, and then part B asks us for the percent yield. So I'll show you how to attack part A and B now. So right away, I would encourage you to go ahead, on your paper or whatever, cross out reactant and products aren't involved in a given problem. In this particular problem, you're concerned with lithium hydroxide and lithium chloride. So I don't really care for potassium chloride, so I'll physically cross that out there on my screen. I also don't care about potassium hydroxide on the product side because that's not involved in this particular example. So you're given 27.4 grams of lithium hydroxide, which is LiOH, and then part A asks you for the theoretical yield. So theoretical is just a fancy way of saying what you should be getting given a certain amount of starting point. Okay. All right. So again, if you notice here, what's going to come up on my screen is this phrase here: unlimited amount of potassium chloride. That is just fancy for saying excess, and you don't really have to worry about the wording there. But just in case you're confused about that. All right, so let's go ahead and do part A. To find the theoretical yield for part A, you would just start with the mass of the reactant that's given. In this case, you're given 27.4 grams of lithium hydroxide in red. So I'm going to actually convert grams to mole because once I have moles with your stoichiometry skill, you can go from mole of lithium hydroxide to moles of lithium chloride. Okay, so let's go ahead and convert grams of lithium hydroxide, which is given as 27.4. And then let's go ahead and convert grams to mole. So this is just going through molar mass. So using your periodic table, if you do the molar mass of lithium hydroxide, you should get about 23.95 based on the periodic table you're using. Okay, so grams of lithium hydroxide is going to cancel out, and that's going to give us 1.14 moles of lithium hydroxide. Now, what you want to do with this is once you know the mole, you can go back to your balanced reaction and look at the coefficients in front of this reactant on the left side and the product on the right side. So the coefficient here is a 1 to 1. So once we know moles of lithium hydroxide, we can find how many moles of lithium chloride should be produced, again, theoretically. Okay, so here I have from mole to mole. You would just carry the previous answer of moles of lithium hydroxide down and then just convert mole to mole. So I would start with that, and then notice here in this middle section here, I have 1 mole of lithium chloride for every 1 moles of lithium hydroxide. So I redirect your attention to the balance reaction. There's no coefficient, so that's just a 1 on the left side, and there's also just some visualize a 1 on lithium chloride. So this one's pretty straightforward, 1 to 1 ratio. So really, moles of lithium hydroxide is going to cancel out. And then you're left with just the same value, 1.14 moles of lithium chloride, which makes sense because it's a 1 to 1. So if you have 1.14 moles of lithium hydroxide, it should produce the same amount of lithium chloride. Okay. But now that you know moles of lithium chloride, you can go from moles of lithium chloride to mass of lithium chloride. So now you just have to do this third step for this particular example. So we're just going to convert 1.14 moles of lithium chloride to mass of lithium chloride, going through molar mass. So here I have to set up again with moles of lithium chloride on top. I'll put the 1 mole of lithium chloride on the bottom. And then using your periodic table, you can find the molar mass of lithium chloride. Okay, so again, give take about 42.39 grams based on the periodic table that you're using. So if we do that, moles of lithium chloride is going to cancel out, and then the only unit left over is grams. So if we take a calculator and we multiply 1.14 times 42.39, you should get about 48.3 grams of lithium chloride. Now, what is the 48.3 grams of lithium chloride? The 48.3 grams of lithium chloride is what you should be getting. Okay, so this answer here is what you should be getting, aka theoretically. Okay, so on paper, that's what you should be getting. However, when you do a reaction in chemistry, you don't always get what you should get. Okay, so essentially, you should get 48.3 grams, but you didn't. Part B says here you only observed that you got 19.2 grams of lithium chloride. Okay, so again, if you do the conversion from mass to mole, from mole to mole, from mole to mass, it tells you you should be getting 48.3. But the problem says you didn't. You only observed that you got 19.2 grams. So the information here is going to help you do part B. So to do part B is pretty straightforward. You would just apply the percent yield function, which is what you actually observe or what you actually get when you do the reaction in a laboratory versus theoretically, which is what is calculated on paper using, starting values. Okay, so here it's pretty straightforward. If you actually read part B, the actual product that you get, and here in the same, this is actual, which is 19.2 grams, so that goes there. And then theoretically, which is what you calculate in part A, which is 48.3. So watch my arrow there. And if you do the calculator work and you multiply it by the 100%, again, this is just converting decimals to percent, you should get a percent yield of 39.8%. So that's pretty much it. You just have to follow this particular function, and it's important that you understand what you need to find, and that is your actual value and theoretical value. Okay, so for this one, all we had to do is really find theoretically how much should have been produced, which is 48.3, and then the 19.2 is given. All right, I hope that helps. Stay nerdy, don't be whack.